Okay, I want to show you a much better way, an easier way, to represent inequalities. Let's start talking about sets first.
Do you mind telling me what this is all about, mister?
Set A intersected with set B. The intersection of set A and B, at least in this case,
Excuse me, Professor Brainiac.
is defined, as hard as it may seem, as all the members X, or the set of all X, such that means such that straight line, such that X is an element of A. That's what the E is an element of A, and also is an element of B. Well, do you see that there's only two members that are both an element of A and of B? So the intersection of A and B is the set containing 2 and 4. That's important for you to understand what intersection. Most people can find that.
Just when I think you've said the stupidest thing ever, you keep talking.
Well, now we want to differentiate intersection with something completely different, and that is a union. A union B is not going to be 2 and 4.
Throw me a frickin' bone here.
Well, A union B is going to be defined as, it's the same definition except the and changed to an or. The set of all X's such that X is an element of A. Remember what element is. Or it's an element of B. So as long as you're in one or the other, you get into the union. And this answer,
Genius. That's what it is. Sheer genius.
please notice, as long as you're in one or the other, you're in there. 1, 2, 3, 4, 6, 8. And notice that 2 and 4, even though they're in both, are not listed twice. Okay? We list everything once. So hopefully you'll see the difference between an intersection and a union. It's much easier to be in the union. Now up to this point, we graphed something like this set, all the X such that X is greater than or equal to 2, with a picture like that. We put a filled in circle on 2, didn't we? And we went to the right because X was greater. I would like you to consider, instead of using the filled in circle, we're going to use, from now on, and I'll show you why in a second, a bracket. Okay? In this one, this would be X such that X is less than or equal to 1. That would have been a filled in circle as well, so we're going to use a bracket there. Now in this one, it's not a filled in circle. X is less than 3. Okay, we could use an empty circle, but what I'm going to have you do, instead of the empty circle or the bracket, because it's not an or equal to, I'm going to use a rounded bracket. I probably should call it a parentheses, right? That's what we're going to use.
I want details, and I want them right now.
Okay, so let me summarize. When we have a greater than or equal to, or a less than or equal to, that means we want to include the endpoint, the or equal to. We're going to use a bracket. Okay, make sure it goes the right way. And when it doesn't include the or equal to, like a less than or a greater than, when we don't want to include the endpoint, we're going to use rounded parentheses. Now, that's going to buy us a whole lot of or at least we have way less effort, and I'll show you why.
And now, ladies and gentlemen, let's get ready to rumble!
Okay, let me show you what these brackets are going to buy us. Normally, when we graphed or represented this conjunction, it looked like that. All the numbers between -2 and 4, and of course filled in dots because of the or equal to's. Now I'm going to ask you to draw it differently with brackets. That doesn't buy you much either, you might think. You still have to do the drawing. And the drawing takes a long time. Okay? I can represent this without going to the trouble of a drawing using what's called interval notation. Interval notation is using the correct bracket or parentheses and showing the leftmost point and the rightmost point. Now in this case, they're both brackets. The leftmost point is -2 and the rightmost point is 4. So you can save yourself drawing this picture by just using this notation, -2 to 4. Let's look at another one. This is, if we drew our old type of picture, notice that the 1 would have an empty circle and the 5 would have a filled-in circle, wouldn't it? Because of the lack of an inequality of an equal sign around the 1. Well, if we start using our brackets and parentheses, you could draw the picture like that. But remember, our goal here is to not have to draw this big picture. And we're going to use interval notation with a rounded bracket next to the 1 and a squared bracket next to the 5, because, of course, there's no or equal to next to the 1. Okay? Now this one's going to be kind of just the opposite with different numbers. Okay, we don't have an equality sign next to the 0, so the 0 gets the circle that's not filled in, and the -4 gets a filled-in circle because he has an or equal to. Now if we write this, well, first let's graph it with the interval notation. Now let's do it the easy way with interval notation with the lowest or leftmost point and the highest or rightmost point. We get this answer. Okay, once again, note that the bracket is next to the -4, the squared off, because he's an or equal to, and I have a rounded parentheses next to the 0 because he doesn't have an or equal to. I do not want to include the end point there. Hopefully you got the idea. Now some of these inequalities, you may remember, go on forever. And if we were to look at a picture of this one, x is greater than or equal to 2, we're going to have to involve infinity. The leftmost number is -infinity, and the rightmost number is +infinity. This picture would look like this. So its leftmost point is 2, but its rightmost point is infinity. And we're thinking we never can really make it to infinity, so it's not going to be an equal sign. So anytime you use infinity, you're going to use a rounded parentheses. So the interval notation that represents this picture is a squared off bracket for 2 and a rounded bracket for +infinity.
Excuse me?
Remember, with infinity, we round it since we never really make it there. Now this one, if you draw the picture, is going to look like this. The leftmost point is not +infinity, it's -infinity, and we never make it there.
3 words. Fabulous.
So we're going to have rounded on that one, and we're also in this case going to have it rounded on the 0 because it's not an or equal to. So that's going to save you drawing that whole picture. So there's your interval notation representation of this picture.
Very bad. Definitely unacceptable. Yeah.
Now what are we going to do with this one? If we want to write it in interval notation, of course it's a disjunction, it's an or, and we need a leftmost point and a rightmost point, and there's a hole in the middle. Well, there's a trick. That's why I'm showing you it.
I'm sorry. I'm afraid I can't do that.
Well, you can do some representation of it, but you can't give me the exact leftmost and rightmost point. Well, you can give me those too, but there's a hole in the middle. We're going to use the union concept. This is the answer, believe it or not. Now, where did that come from? I want you to see that the interval here represents the leftmost picture there, from negative infinity up to negative 1. And the other part of it is represented here, from 6 to positive infinity. And since we can't really have a whole picture without a hole in it, if you would, we're going to just use the union and put the two mini pictures together. Okay, so anytime you have a disjunction, you're going to have to use the union. Okay? Well, let's solve one and get an answer. To solve this, basically it's two little problems. We'll solve them separately. Okay? The left problem will subtract -5, or add a -5 if you would, to both sides. And then we'll divide both sides by 3. Now this is the big leagues. Sometimes things don't come out even. 5/3. Where is 5/3 on the number line? Well, you should write it as a mixed number. 1 2/3. Right? So it would kind of look like that, wouldn't it? Now this is a disjunction, so it's an or. So I'll solve the other problem separately. Subtract 1 from both sides. And how do I graph x is greater than 3? That's going to be a rounded endpoint there. And I'm going to have to use... We need to use union man, okay? And basically we just union the two answers, I hope you appreciate. From negative infinity to 1 2/3, unioned with from 3 to positive infinity. Note also that every time we use infinity of any kind, we have a rounded parentheses. Okay? Here's a conjunction. Now, a conjunction, when you have to solve it, really has 3 sides. So whatever I do, I'm going to have to do 3 times. To get x alone, I have to subtract 3. So I'll do it to all 3 sides. Okay, now I need to graph this. Basically, it's all the numbers from -2 to 5, and it's inclusive because they're or equal to's. So this is pretty easy to write in interval notation. Just brackets around both because it's or equal to. The lowest number is -2, or leftmost, and the rightmost number is 5. And there's your answer. Let's do another conjunction, solving it as a 3-sided equation. We add 5 to all 3 sides. Now how do I get rid of a half? Well, I'll multiply by the LCD. And I'll get x is greater than 6 and x is less than 12. But there's no or equal to here. So I use a rounded bracket, and it's a conjunction. Okay, let me do a couple tricky ones. We've got to get x alone. I have fractions. Remember the trick for fractions. Multiply everybody by the LCD. So in this case, that 3 will nicely go away, and I'll end up with what I have here. Now I still have to get the x alone, so I'll add 1 to all 3 sides, and then divide by what? Divide by -2, because that's who's multiplying the x. Well, when I divide by a negative number, what do I have to do?
Does everybody know what time it is?
It's time to flip the signs when I divide by a negative number. There was no escaping it. And if I do that, I get x is smaller than 4 and greater than -5. You have to read this backwards. X is smaller than 4 because the mouth is opening to the 4, and x is greater than -5 because the mouth is opening to the x. This is going to be a conjunction. The number's smaller than 4, and at the same time greater than -5. Well, what's both pink and blue is the intersection, isn't it? So that's a picture of the answer.
You just won $1 million.
And that's the interval notation. Okay? Doesn't get much harder than that. Now let me change this problem just a tweens. And it's going to change everything. I have the same problem except the signs have been changed to the other way. Okay? Still going to use your LCD, man. Still going to add 1 to everybody. Still going to divide by -2. And since I divide by -2, what am I going to do? I'm going to flip the signs. Now you got to be careful. What is both, because it's a conjunction, greater than 4? X is greater than 4. The mouth's opening up to the X, isn't it? And also less than -5.
The important thing is it your final answer?
Well,
Houston, we have a problem.
there is no intersection. There is nothing that is both blue and pink. So guess what the answer in this case is? There is no. The answer is
You are correct, sir.
the empty set. Sometimes that can be the answer. So be looking for that. Well, okay.
Does everybody know what time it is?
Go try practicing this. It's kind of challenging. Anything can happen, okay? And be watching for the difference between a conjunction and a disjunction.